Hey you guys, welcome to one more Hui Raptor video. A few weeks ago, we made a video showing the new plug-and-play board for the Creality Ender 3, the Cheetah version 1.1 from Fysetc. We were going to install and make a video of it, but several users reported issues with it and Fysetc designed a new version that would fix some of those issues. So because of that, we decided to wait for the new board to be released and test both. The first released version, the 1.1, was equipped with TMC's 2209 drivers and some other cool features. But because these drivers from Trinamic were new, they ran out of stock and Fysetc released an alternative version with TMC's 2208 instead. The main differences are a higher stepper motor max current output and sensorless homing feature with the TMC's 2209. Since the board was designed for the Ender 3, the max current output of the TMC's 2209 was never going to be reached, and the sensorless homing was not yet implemented correctly in the firmware, so going back to the TMC's 2208 was not that big of a deal. The biggest issue was the problems detected with these boards by users that bought them. The main one that was brought up by the community is the bad and hot end MOSFET behavior. It was detected that no matter what, the bad MOSFET was leaking a small amount of current. That can be seen with the LED partially lit. If we connect the voltmeter to it and only turn the main power on, we can see 2.5 volts at the heatbed output connector. This output should always be off until you command the heatbed to turn on, and at that point, you should have 24 volts. Well, 2.5 volts in a 24 volt system like the Ender 3 is not enough to heat up the bed and give you problems, but the fact is that the design is clearly wrong here. We tested the new 1.2 version and this issue no longer exists, meaning that the manufacturer fixed the issue. Regarding the hot end MOSFET, some users reported that with the board connected to 24 volts and when connecting the USB cable from the PC to the board, the hot end MOSFET would turn on without any control. Well, we tested this here with our 1.1 version and we could not see that problem. We even turned on the temperature to check if the LED was working correctly, and it is. Maybe only some units were shipped with that issue. That we don't know. We also tested this with the new 1.2 version, and we don't see that either, which means that this issue is most probably fixed. One other issue that was raised was that with the board connected by USB, some voltage was flowing from the USB connection back to the main 24 volt circuit. That is also true, and we measured 3.57 volts flowing back in our board. Although this is clearly a design flaw, it's more common than we might think. For example, we found that the Creality 1.1.5 silent board outputs 3.97 volts. And the stock board that comes with the Ender 3 outputs 4.1 volts. We measured again with the new version, and this time we only get 1.08 volts, which is much better and it's okay. It seems that Fysetc also fixed this issue with the new board. One other concern was that the board was unable to save settings to the EEPROM. If you wanted to change the setting on the display, you didn't even get the store option in the menu. Later, a firmware update enabled that option, but you could only save to the memory card, and if that card was not present at power on, the changes would not be there. Although this new board does not come with the store option available, the latest firmware versions will enable it, and it's now possible to save the changes directly to the internal memory without the need of the memory card. This works for both version 1.1 and 1.2. On both versions, you have the option to choose between 12 volts and 24 volts output for the cooling fans. This is a very handy feature if, for example, you decide to install 12-volt Noctua fans instead of the stock 24-volt ones. With the older 1.1 version, if you want to have 12 volts, you need to get an external step-down module and install it over the board. With the new 1.2 board, you no longer need the extra module, since the 12-volt step-down is already included in the board's circuitry. You only need to use jumpers to select between 12 and 24 volts. We also noticed a couple of things that you need to check while installing these boards. One is regarding the hot end fan connection. This board is meant to be a direct replacement and plug-and-play installation. However, Fysetc did not include the hot end fan screw type connector. The hot end fan of the Ender 3 is connected directly to 24 volts and therefore always on. So you need to connect the fan wires together with the 24-volt input wires coming from the power supply. In our case, and because we don't like to run printers with the tin wires connected to screw-type connectors, we always crimp ferrules on those wires, and these were no exception. And having said that, we had to cut the ferrules out and crimp new ferrules with both wires in. The new version is announced to have a controlled output for the hot end fan, and it's this connector right here, where on the stock board it's used for the case fan. This means that both fan outputs are independent and PWM controlled. So if you want to connect the hot end fan here and control it with the firmware, like for example to turn it on only when the hot end temperature is above 50 degrees C, you need to crimp a compatible female connector to the hot end fan wires. One last thing about the screw type connector pins, the ones used by Fysetc are longer when compared with the ones used on Creality boards. You need to be careful because these pins will be too close to the metal panel of your printer. If by any chance these pins touch the metal plate, they will short out the power supply. We recommend you to isolate the metal plate where the pins will be to avoid any shorts. One other thing that was mentioned by some users was that the knob was turning the wrong way in the menus. Some other printers have it this way and it's not very user-friendly. To reverse this, we just need to change this line here in the firmware. The 1.2 board already has the knob turning the right way. With the 1.1 board, if you power the board with only the USB cable, the screen information will be a bit hard to read. Although the 1.2 board is also dimmed, we can now read clearly the information on the screen. Now that we cleared all the issues, let's install the board and test it out. Don't forget to place the heatsinks and the jumpers before installing the board because it will be much easier to do this with the board out. Start by labeling all the wires that don't have any tags on them and disconnect all of them. Remove the old board and install the new one. For the screw type connectors, make sure the screws are tight and the wires secure. If you have a BL Touch, you can connect the probe and power pins here, and the Z- signal you connect it to the Z end stop connector. Pay attention when making the BL Touch cable. The voltage and ground pins are in a different position when compared with the BL Touch. Also, the output voltage for the BL Touch is only 3.3 volts in the 1.1 board, while the 1.2 board is 5 volts. We still see 3.3 volts on the silk screen, but that is a typo. For the case fan, and like we mentioned before, we need to connect this fan to the 24-volt power pins because we will want to have this fan always on. Close the panels and turn on the printer. Like we said before, we recommend you to update the firmware first, so connect the USB cable to the printer and to your computer. We tested two different firmware sources, one from the Fysetc wiki page and the other from this link on GitHub, which includes a lot of firmware versions, but we will talk about the results in a minute. So, download and install the FlyMCU software that you can find on the Fysetc wiki page. You can check the link below in the video description. Open the software and confirm that this line here at the bottom matches the one we have here. Select the firmware location and then click on Start ISP. A few seconds later, you should see the upload complete information on the screen. Remove the USB cable, turn on the printer, and you're ready to go. The TMCs will provide a better print quality when compared with the stock board, which is equipped with Allegro drivers, since they will eliminate the salmon skin effect. Here we can see the difference between the stock board with the Allegros and the Cheetah with the TMCs. The new drivers will also make your printer run with less noise. With the 1.2 board, we get temperatures between 36 and 38 degrees C on the stepper motors, which is perfectly normal. And you can always tweak the output current for each axis in the display at any time. If you have dampers installed in your motors, you should remove them. As for the firmware versions, there are still some improvements to be done. The ones provided from Fysetc work pretty well except for the BL Touch version because it's not accepting the G29 command that we include in the start G-code to run the mesh sequence and map the bed. When starting the print, it will home all the axes including the Z with the BL Touch at the center of the bed, and then ignores the G29 command and proceeds with the print. The versions from GitHub are more complete, but we noticed other issues. The BL Touch G29 command works and it probes the bed in a 4x4 probing sequence but randomly fails to send the correct output current value to the TMC drivers, which makes the motors run with a much higher current, causing them to overheat and skip layers while printing. This happens with both BL Touch and no BL Touch versions. So until this issue is fixed, we recommend to use only the firmware versions from Fysetc's wiki page. At the moment we release this video, Fysetc is announcing that version 1.1b with the TMCs 2209 will be back on stock soon and will include all these fixes. From what we know, there isn't any firmware version working with the sensorless homing feature at this point. Although Fysetc is still working on that firmware, we will have to wait a bit longer if we want to use that feature from the TMC's 2209 boards. And that's it, you guys. Don't miss the next upgrade videos where we will test and show more plug-and-play solutions for the Ender 3. If you are not a subscriber yet, click on subscribe and activate the bell so that you can be warned every time we publish a new video. If you like our work and wish to help the channel, you can with Patreon or PayPal. Check the description below on how to help. As always, keep following us here on YouTube, Facebook, Instagram, and Twitter. We will see you guys next time. Bye!